In the year 476, the last Roman emperor in the West was pushed off his throne by a soldier who did not bother to replace him. That is the year people mean when they say Rome fell. The same year, on the other side of the world, a boy was born in India. 23 years later, he sat down and wrote 121 verses. Inside them is a complete mathematics and a working model of the sky. His name was Aryabhata. This is what he actually did, and what he has spent 1,500 years being wrongly credited with. Let us start with his life, because it will not take long. He wrote a book. He wrote a second one, which is lost. And somewhere in the first, almost in passing, he mentions how old he is. That is the lot. No family, no teacher, no death date, no face. The portrait you have seen of him is a statue somebody carved in the 1970s. So his birth year is not a record. It is a calculation. And here it is. He writes that 3,600 years of the current age had gone by, and that he was 23 at the time. That age begins in 3102 before the Common Era. Add the 3,600 and you land on 499. Take off the 23, and he was born in 476. Every date you will ever see attached to this man comes out of that one line. Where is harder? He tells us he worked at Kusumapura, which is modern Patna, in Bihar, in the northeast of India. That is his own word, so we can take it. But his first commentator calls him a man of Ashmaka, and Ashmaka is more than 1,000 kilometers to the southwest. So the honest position is this: we know where he worked. We are guessing where he was born. It is worth stopping to place him, because 499 does not mean very much on its own. Euclid is nearly 800 years behind him. Ptolemy about 400. Ahead of him, Brahmagupta is a century away. Al-Khwarizmi, 3 centuries. Fibonacci, 7. And Copernicus, the man we usually credit with moving the earth, will not be born for another 997 years. The book is called the Aryabhatiya, and the first thing to say about it is how small it is. 121 verses, in 4 parts, 13 on cosmology, 33 on mathematics, 25 on time, 50 on the sphere, which means the whole of the mathematics, all the arithmetic, the algebra, and the trigonometry, is 33 verses, about a quarter of a very short book. There is a reason it is that tight. A text like this was not mainly something you read. It was memorized and recited and carried between places inside somebody's head. So every verse has to survive being spoken aloud by a person who may not fully follow it. That one constraint shapes everything that comes next. It is why the mathematics is compressed until it almost hurts. Start with how he writes numbers, because he is not using the ones you are expecting. He builds a number out of syllables. The consonants carry the values. The first 25 run 1 to 25, then they jump in tens up to 100. The vowels multiply by successive powers of 100. So a string that looks like a nonsense word is a number. This one is 57,753,336. Nobody else ever used this. Not his commentators, not his successors. It turns up once, in him, and then it is gone. But look at what it holds. 9 vowels, each one a factor of 100 bigger than the last, gets you to 10 to the 18. In one written word. In Rome, at that exact moment, writing down 1,000,000 was already awkward. Now the verse everybody quotes. Watch what it actually says. Add 4 to 100. Multiply by 8. Add 62,000. That, he says, is the circumference of a circle whose diameter is 20,000. So do it. 104 times 8 is 832, plus 62,000 gives 62,832. Divide that by 20,000. 3.1416. That is pi right to 4 decimal places in the year 499. And there is one more word in that verse worth having. He calls the answer asana, approaching, approximate. You will read that this proves he knew pi was irrational. He may well have suspected something. But one adjective is not a proof, and people have been arguing about that word for over a century. So the value is his, certainly. The claim about irrationality goes in the maybe column, and it stays there. The next thing he does is bigger than the pi, and hardly anybody mentions it. The Greeks did their trigonometry with chords, the full line straight across a circle. Aryabhata works with half of it instead, measured from the middle of the arc. That is the sine. And this is the first table of it that anybody wrote down. 24 values, 1 every 3 3/4 degrees, from nothing up to a right angle. He does not list the values, though. He lists the differences between them, which is a much cleverer thing to do. It makes the table shorter to memorize, and it means you can get at any angle in between with nothing harder than addition. Remember where this has to live. Inside somebody's head. And now the part I find genuinely funny. His word for that half chord is jaya. It travels into Arabic as jiba. Now, Arabic doesn't write its short vowels, so on the page that is just 2 letters. JB. Centuries later, a Latin translator meets those 2 letters and reads them as jayb, which is a real Arabic word. It means a bay, or a fold in a garment. So he translates it faithfully. And the Latin for bay is sinus, which is why, if you ever sat through trigonometry at school, you spent years writing down a word that is simply a mistake. Sine is a mistranslation of a Sanskrit term for half a chord. There is one more piece of mathematics in here that deserves its name. He needed to answer questions like, these 2 planets have these 2 periods, so when do they line up again? That is an equation where only whole number answers count, and those are genuinely hard. His method is called kutaka, the pulverizer. You take the 2 numbers and grind them against each other, remainder by remainder, until what is left is small enough to just look at. Then you climb back up. If you have met the extended Euclidean algorithm, you have met this. He is doing it in verse, 1100 years before Europe writes it down. Then he does the thing that gets him argued with for the next 1,000 years. Anyone can see the stars go round once a night. The obvious explanation is that the stars are moving. Aryabhata says no. It is us. And listen to how he argues it. A man in a boat going forward sees the bank going backwards. That is the whole argument, and it is right. He does the same thing to eclipses. The explanation he grew up with was a demon called Rahu, swallowing the sun and the moon. Aryabhata puts geometry there instead. The moon goes dark because the earth's shadow falls across it. The sun goes dark because the moon's shadow falls across us. And then he does the bit that makes it science rather than an opinion. He works out how long it will last. So how good were his numbers? 2 answers, and they are not the same answer. The length of a day, measured against the stars, he gives as 23 hours, 56 minutes, and 4.1 seconds. The modern figure is 4.09. He is out by 9.5 milliseconds. The year he gets wrong, 3 minutes and 20 seconds too long. Over a few centuries that drifts badly, and his successors spent a great deal of effort patching it. Which brings us to the thing everybody says about him. And it is not true. Aryabhata did not invent 0. The rules for 0 as a number, what happens when you add it, subtract it, multiply by it, come from Brahmagupta in 628. That is 129 years after the Aryabhatiya by a different Indian mathematician who deserves the credit and rarely gets it. What Aryabhata had was place value. His numbers know the difference between a digit in the tens column and the same digit in the hundreds, and his whole system falls apart without that. But there is no symbol for an empty column anywhere in his book. And that symbol is the hard part. Plenty of cultures got to place value. Almost none of them took the next step, and treated nothing as a number you could actually calculate with. While we are here, 3 more that get repeated. That he ran the university at Nalanda, said everywhere, evidenced nowhere. That he was a heliocentrist, that he had the Earth going round the sun. He had the Earth turning, which is remarkable and quite enough. The orbit is a much weaker case, and most scholars do not buy it. And that word asana again, as proof he knew pi was irrational. Still a maybe. One more piece of honesty, and then we are done. While Aryabhata was working, there was a man called Zhu Chongji in China doing the same job. His value for pi was 355 over 113. Work that out, and you get 6 correct decimal places against Aryabhata's 4. And Zhu had already squeezed pi between 2 bounds that pin down 7. He died in the year 500, 1 year after the Aryabhatiya was written. 2 people who never heard of each other on opposite sides of the Himalaya at the same moment. And the better number is not the one in this video's title. Here is where I want to leave the timeline. In 499, a 23-year-old in India writes down that the Earth turns and explains it with a boat. Copernicus is not born for another 997 years. He does not publish for 1044. None of this makes Aryabhata a modern scientist. He believed things that are wrong. He worked inside a cosmology of world ages lasting millions of years, and his year is 3 minutes too long. But he did something you can still recognize from here. He looked at an explanation everyone around him accepted, decided it did not fit, and put in its place one that could be checked. And then he squeezed the whole thing into 121 verses, so that somebody could carry it. Everything in this video was checked, and anything that did not survive the checking was labeled on screen as it came up. Verse numbers and sources are in the description. Thank you for watching. If you would like more of these, subscribe.